Add my 3a to both sides, and I'm also taking away 2 from both sides. So I have now 6a is equal to negative 1, and then I'll divide by 6, cancel that out, and I have negative 1/6. 1x on this side is equal to negative 2. 7 to what power?
Oh, 2.
2. So that's the answer. Alrighty, and then this one's a little bit tougher, but 6 times 6 is 36, times another 6 is 216. So 6 to what power gives you 216? 3. So that is all you had to do for 3 and 4. We're going to add 1 to both sides, and now we've got 13 over 3 is equal to v. You just divide by the amount of v that we have to isolate the variable. This one, I want to make my variable positive at all times that I can. So I add 5p to both sides, and I've got 2p plus 6 is equal to negative 4. I'll take away 6, and then I have 2p is equal to negative 10. Divide by 2 is log base 7 of 83 is equal to x. So 7 to some power x gives you 83. Both of these mean the same thing. However, in order to solve it, we actually need to use our change of base formula, considering we were all using the basic scientific calculators here. So this base is going to go in the basement here. So it's going to go right there. I have log of 7, and in the numerator, log of 83, 2.27. So the next one, we actually have to divide first by negative 10. So it ends up with, well, I'm going to rewrite it in our logarithmic form already. So log base 19 of negative 40 divided by negative 10 is just going to be 4 is equal to 10m. So again, we'll need to rewrite this with our change of base formula. In order will be my 4. So my new base is 10. So I have log base 10 of 4 over log base 10 of 19. I divide the whole thing by 10, and then I get m. 0.05 over v. Expanding that would just be log of u minus log of v. So division and subtraction, they go back and forth. If this was log u times v, it would be log u plus log v. Write this. Let's keep it together for now. So you've got log base 5 of a cubed b to the 15th power, 3 log base 5 of a plus 15 log base 5 of b. So those numbers came from the exponents. What I ask you to do is just to simply rewrite it as 15 squared is equal to 225. 19 squared is equal to 361. Then you have to write this one. The base is 6, the base is 13. You just put the word log in and you rewrite the numbers. So you've got log base 6 or log base 13 of this number here, 1 over 36, 169 is equal to negative 2 is equal to 2. You just had to rearrange the numbers to the exponent of that, and then this goes to the exponent of that. So what we end up with is log base 5 of 8 cubed over, we've got 3 times 11 to the 6th power. I have log base 9 of x, y, z. The whole base here is 10. So what ends up happening is we have 10 to the x is equal to 4y, right? So this one, not a whole lot is going on. It's base 2, so we have 2 to the x is equal to y plus 3. And the next step for both of them is just to simply isolate the variable. In this case, it's multiplied by something, so we have to divide through the inverse operation. In this case, it's the variable plus something, so we have to subtract. So our final answer is 10 to the x over 4, and that's just y. And then this one is 2 to the x minus 3 is equal to y plus 3. So x minus 1 has to be greater than 0. So this means that any number x that is negative 3 or less doesn't work. And then minus 3. So this is going to turn into our negative 1 minus 3, a negative 2.2. And for x, well, we're going to end up with our negative 1 for the logarithm, and then plus 3, so y will be 2. Plus 3, and it's 4, comma 3.5. So we've got in the numerator log of x minus 1, in the denominator log of 2. So our first x value is 1.5, so 1.5 minus 1, we have log of 0.5. So we get a negative 0.3, and then we're dividing it by log of 2. So we end up with our y is equal to negative 1 minus 3. We don't want to forget about this minus 3 right here. So when x is 1.5, y is negative 4. So if we go ahead and do all of that with 6, then let's go ahead and write 6 right here. So pretty much the same process. X is 6, y is negative 0.7, equal to log of x plus 5 over log of 4, and then we take away 4. But 10 to the 0 power gives us 1. So we have the numerator being 0, and then the denominator doesn't matter. So it's just 0 minus 4. So conveniently, when x is negative 4, y is negative 4, negative 2.4 for x. So we have y is equal to 3 times 2 squared, and y is going to be equal to 3 times 4, or 12. Same thing with this one. When it comes to 24, when x is 0, it's 1/2, this one as well. So now we've got 1/2 times 4, which is just 2. Where did this 4 and this 2 come from? 2 times 1 or 4 times 1? Because when you do the 0 power, it's 1. Now 2 times 3 is just 6. 4 times 2 is just 8. We have y is equal to 2 times 3 squared. Y is equal to 2 times 9, or 18. The initial cost of the Lamborghini multiplied by the 1 to represent that initial cost, minus, because it's depreciating, decreasing in value, just 0.1, and the time power in this case would be 5 years is what you would plug in. So this is also the same as 0.9. On all the test IDs, including the one you had, this was all the same question. So it was D, and you should have had 0.9 to the T power. When you plug it in, you would put 5 there for your power, and then you would end up with about 156 grand if you tried to sell your Lamborghini after 5 years. So for 28, the company had lead sales in 1993, and that was your initial amount. It was increasing over the 19 years between 1993 and 2012 by 2.7%, and that's a 19-year difference. So you plug that into your calculator, the exponent of time would be 19 years. This represents 2.7%. Do we know how to go back and forth from percents and decimals? So that's that. 29, and a lot of people got these wrong, so you guys should really still be paying attention. 3,500 animals decreases, so initial amount 1 minus 0.29, which is 0.71. So if you would just put the 2.9, which I made there as a deliberate answer choice, so you would get it wrong, not because I wanted that, but because I need you to know how to do it the right way. So this is still to the T power, in this case 3. So this represents a 29% decrease from the initial amount of 100% total animals. And if you would just put 29 in there, it would represent a 71% decrease. So we gotta make sure we put our numbers in the right places. And then for 30, you would have to set it up in order to have over $9,000, you would have to solve for some value X, the initial amount, 1. You divide both sides by this part here in order to get your answer.